Page 425, number 7, model with math. The equation y equals 15x can be used to determine the amount of money y Polly's Pizzeria makes by selling x pizzas. The graph shows the money Leo's Pizzeria takes in for different numbers of pizzas sold. Which pizzeria makes more money per pizza? So again, money per pizza, that's a unit rate. And so we're just looking at the information and determining which one is going to be making more money. So when we look at Leo's Pizza, we can see that the graph is going up by 24 each time, which means that the line in between 0 and 24 would be 12 because that's halfway. So this would be 36 and so on, adding 12 each time. And down here on the x-axis we have 1, 2, 3, 4, 5 and so on. So we can see for one pizza, Leo's Pizzeria is going to make $12. This is our y-axis, this is our x-axis. So when we look at the unit rate or the constant of proportionality, we use y over x, and we can see that that would be $12 per one pizza. So Leo's Pizzeria is making $12. If we were to write this in an equation that is similar to this equation format, again, we're simply rearranging these letters so that we have y all by itself on one side. So k equals y over x. The way we do that is we're going to multiply both sides by x over 1. Because then our x's will cancel on the right-hand side, and we'll have y left on the right-hand side, and on the left-hand side we'll have xk, but I'm going to switch things around and bring my y to the left, and I'm actually going to switch these two around and put kx. I can do that because these are multiplication. So if I know that my k value is 12, then this equation for Leo's Pizzeria is y equals 12x. And they're telling me that the equation y equals 15x is the amount of money that Polly's Pizzeria would make selling a certain number of pizzas. So Polly's Pizzeria, if 12 represents the amount of money that Leo's Pizzeria takes in for one pizza, and it can be represented in this format, that means that the number in front of the variable x is the amount of money they make per pizza. So Leo's Pizzeria takes in $12 per pizza, and that means that up here this quantity is the amount that is taken in by Polly's Pizzeria. And so it just makes sense that Polly's Pizzeria is going to make more money. Number 8. The graph shows the amount of savings over time in Eliana's account. Lana, meanwhile, puts $50 each week, there's my unit rate, into her savings account. If they both begin with 0, who is saving at the greater rate? So it looks like Lana has a rate of $50 per week. And when I look over at the graph, I can see my x-axis is my time in weeks, my y-axis is my total in savings. You can see I started with 0, And I know that from 0 up to this first indicator that they gave us, 94, I know half of that is 47. So this line right here would be 47. So 0, 47, 94, this would be 141, and so on. So I can see that if I fill in the missing numbers on my x-axis, that in 1 week, Eliana is putting $47 in. So Eliana's account is growing by $47 per week. Who is saving at the greater rate? Lana is, or Lana, because $50 a week is greater than $47 a week. Page 426. Number 9. Make sense and persevere. Beth, Manuel, and Petra are collecting sponsors for a walkathon. The equation y equals 20x represents the amount of money Beth raises for walking X number of miles. The table shows the relationship between the number of miles Manuel walks and the amount of money he will raise. Petra will earn $15 for each mile that she walks. So Petra's unit rate, $15 for each mile, is going to be Petra. Up here, this is Beth, and Beth is going to be earning $20 per mile because that 20 in front of that X variable is the unit rate. If I wrote an equation for Petra, it would be y equals $15 times X. So over here is Manuel, and I can see that the money raised and the miles walked, this is going to be my X, this is going to be my Y, and I'm going to take Y over X and see what I get. So 45 divided by 3 is 15, and I'll just double check the rest of these to make sure that they're proportional. 75 divided by 5 is also 15. 105 divided by 7 is also 15, and 135 divided by 9 is also 15. So these are proportional, and Manuel then also is raising $15 for every 1 mile that he walks. So part A, in order to compare the proportional relationships, what quantities should you use to find the unit rate? Well, the unit rate is going to be how much money is raised and the other quantity is miles walked. Compare the amount of money raised per mile by the 3 people. So we can see that Petra is going to earn $15 per mile. We can also see that Manuel is going to earn $15 per mile. And Beth is going to earn $20 per mile. And that's all they want us to do. We could put signs in here I guess, greater than and less than signs. Petra and Manuel earn the same amount per mile. Beth earns the most. Per mile. Number 10. Winston compares the heights of two plants to see which plant grows more per day. Per day. There's our unit rate. Growth per day. The table shows the height of plant 1. Here's plant 1 in centimeters over 5 days. The graph shows the height of plant 2 in centimeters over 10 days. Winston says that since plant 1 grows 6 centimeters per day and plant 2 grows 4 centimeters per day, plant 1 grows more per day. It says, do you agree with Winston? Explain your response. So here's our graph, and we can see that our y-axis is increasing by 2 centimeters each time, and our x-axis is increasing by 1 day each time. So at 1 day, the plant is growing 2 centimeters. That's our unit rate. That's our constant. 2 over 1, that's our y over our x. So that is 2 centimeters per 1 day. So if we were going to write an equation, that would be y equals 2x. Over here, for plant 1, this is our x, this is our y. When we have k is equal to y over x, that's going to give us 6 over 2, which is going to give us k is equal to 3 centimeters in 1 day. And if we were going to write an equation for that, our equation would be y equals 3x. So plant 1 is growing at a rate of 3 centimeters per day. Plant 2 is growing at a rate of 2 centimeters per day. So plant 1 is growing at a greater rate. And Winston says that plant 1 grows at 6 centimeters per day and plant 2 grows at 4 centimeters per day. So plant 1 grows more per day. Do you agree with Winston? Well, plant 1 does grow more per day, but the reasoning that Winston uses is not appropriate. What error might Winston have made? Winston did not determine the unit rate. Or the constant of proportionality. Number 11. Ashton, Alexa, and Clara want to know who types the fastest. The equation y equals 39x models the rate at which Ashton can type. So we've got Clara's typing represented in a graph. We have Alexa's typing represented in a table. And we have Clara's or Ashton's typing represented in an equation. So we know that Ashton types at 39 words per minute. That's generally how that's written when they're talking about typing speed. Where y is the number of words, so y is equal to 39x, and x is the time in minutes. The table shows the relationship between words typed in minutes for Alexa, and the graph shows the same relationship for Clara, who types the fastest. So we know that this is Ashton. And let's look at Alexa. Alexa is, these are all proportional, by the way, I've already checked. So let's just use the simplest, 78 and 2. So we're going to have k is equal to y over x, k is equal to 78 divided by 2, k is equal to 39. So that means when we write an equation for Alexa, we're going to write y equals 39x. And when we look at this, we know that this means that her speed is 39 words per minute. So she's the same. Alexa and Ashton have the same speed. Let's see what Clara's is. On my y-axis, things are increasing by 78 for every 2 lines. So that means that it is increasing here at 39. So every line is representative of 39. And because my x-axis is my time in minutes, I know that in 1 minute, Clara is typing 39 words. So k equals y over x equals 39 over 1. So that's 39 words per minute. And my equation is y equals 39x. So the question is, who types the fastest? They all type the same speed.